today we're talking about perpendicular lines, and perpendicular lines are lines that intersect to form right angles or 90-degree angles when they cross each other. So when we were talking about parallel lines, those are lines that never intersect. And if you have two lines that are on the same plane that are not parallel, that means they're going to have to intersect at some point. Well, perpendicular lines are just a special type of intersection where they cross at 90 degrees. And kind of the definition that they use is that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. That's kind of confusing. Basically what I want us to take away from this is if we look at these two lines on the left side here in this left graph, we've got two lines in slope-intercept form, and they form a 90-degree angle. And the slope of this line is -2/3, and the slope of this line is 3/2. Now if we multiplied those two together, we would get -1, which is what they're talking about in this definition. But what I want us to take away from this is that those slopes are opposite reciprocals of each other. Opposite recips. Okay, so they're opposite reciprocals, meaning if I ever want to get a perpendicular slope or a 90-degree angle slope for an intersection, I just flip the slope and switch the sign. And then the right graph here just shows us that vertical lines and horizontal lines will always be perpendicular to each other. Okay, so let's use that knowledge of the opposite reciprocal to prove that PQR is a right triangle. Okay, so if PQR is in fact a right triangle, that means we have to have an angle, and it looks like it's probably going to be this one, that has opposite reciprocal slopes. So I'm going to take this line right here, and I'm going to find the slope of it. So there are a couple ways you can do that. You can use your slope formula if you want to, or we can just do a little bit of rise over run. So let's do rise over run. Alright, so I'm going to go over 1, 2, 3, up 1, 2. So I rose 2 and went over 3. So that has a slope of 2/3. Okay, now if I look at this line, I'm going to go over 2, 1, 2. So again, rise over run. So I went over 2, that's my run, and now I'm going down 1, 2, 3. Notice how we have opposite reciprocal slopes, -3/2 and +2/3. You flip it and switch the sign. This means we have a right triangle. So this right here, or that means we have that 90-degree angle going on between those two segments, meaning we do have a right triangle. So we can officially say that PQR is a right triangle. Alright, identifying perpendicular lines. Remember, horizontal lines and vertical lines will always be perpendicular to each other. So these are perpendicular. This is the symbol for perpendicular, by the way. And to check the other two, let's see if they're perpendicular. So this one has a slope of -4, since we're in slope-intercept form. So let's check this one. Nothing's really going to change here. Even if I turn it into slope-intercept form, I've got 1/4 x plus 1 times 1/4, and y plus 2 equals this. I would just subtract 2 on both sides, and it doesn't even matter what this comes out to, because here's all I need to know. My slope is 1/4, which is the opposite reciprocal of this one. So if I compare the two slopes of each line, I have 1/4, and then I have -4, but I can write that as -4/1. Opposite reciprocals, flip them, change the sign. So this and this are also perpendicular to each other. And lastly, just like we did with parallel equations, we can write an equation in slope-intercept form of a line that passes through the point 3, 2 and is perpendicular to, no longer parallel to, the line described. So this line right here. So the slope of this line is 3, but we need the slope of a line that's perpendicular to that one, meaning I'm going to take 3 over 1. I'm going to flip it. So here's our slope that we need. I'm going to flip it to 1 over 3. And I'm going to change the sign. So we need our slope to be negative 1/3. And then we have a specific point that we can use. Got x1, y1, and I'm going to use point slope form to come up with our equation. And then we'll be done. So I'm going to take my slope that I need, because it's got to be perpendicular. So I'm perpendicular to this equation. So I need that slope to be negative 1/3. X minus my x term, which is 3, equals y minus my y term. And then I just do a little distributive property because I wanted it in slope-intercept form, so I got to solve for y. So negative 1/3 times x, and negative 1/3 times a negative 1, or negative 3 is going to be positive. And 1/3 times 3 is just 1. Alrighty, and to put it into slope-intercept form, add 2, just solve for y, and we are left with y equals negative 1/3 x plus 3. Notice how the slope of this equation and the one they gave us have opposite reciprocal slopes. That is our answer. And we have come up with an equation that is perpendicular to the given one and passes through the point that they gave us. Alright, that's all I've got for you today. It's very similar to figuring out stuff with parallel lines, except for now we're talking about that special intersection of 90-degree angles.